All right. So we are factoring the difference of two perfect squares. First of all, I want you to notice in all of these problems, as you look, A, B, C, and D, how many terms do you have? How many terms? Is this a monomial, binomial, trinomial? Binomial, yeah, two terms, okay? So difference of two squares means you are going to have two terms, and you will always have a subtraction sign in between them, okay? You also should try to recognize that each of those terms, they are a perfect square. So if they are a perfect square, that means we should be able to take, as we look back up here at the symbols, right up here, if I have a squared minus b squared, I should be able to take the square root of that, okay? And that square root of a squared is going to be a. That a becomes the first part of each of the two factors, minus the square root of b squared, which is going to be the b that happens right there. Yes, Miss Dee Dee. Yes. Mm-hmm. Okay. Uh-huh. Bye-bye. Okay. All right. So you take the square root of each one of those. For the first factor, you put a plus sign in between. And for the second factor, you put a minus sign in between. Or you could switch it. It really doesn't matter. Okay. But usually I always put the plus sign first and the minus sign second. All right. So let's take a look at the next example. X squared minus 9. X squared, that is a perfect square. X times x gives you x squared. So you take a square root, and that square root is going to be x. That goes as your first term in each of those factors. Okay? Minus 9. 9 is also a perfect square. What value times what value gives you 9? What number times itself gives you 9? 3. And so you put that square root of 9 as 3 here. Put the plus sign here for the first factor and the minus sign here. Okay? And they show you a third one. Now you can also have 4u squared. You can have a number with a variable. You take the square root. First of all, 4 is a perfect square. What number times itself gives you 4? 2. So that 2 goes here, and then u squared is also a perfect square. That would be u times u. So that's 2u and 2u. And then, I don't know if you've ever thought about this, but 1 is a perfect square. 1 times 1 gives you 1. So the square root of 1 is 1. And you put a plus sign in the first factor and a minus sign for the second factor. Okay? Any questions about those examples? All right, so let's get to the actual mathematical examples. Now, here, when we are factoring, what do I always need to look for first, though? Greatest common factor. We still need to do that. So you look at your smallest coefficient. In this case, it's 64. Does 64 go into 81 evenly? No. So we got 1 and 64. We got 2 and 32. Does 32 go into 81 evenly? No. 3 is not a factor of 64. 4 is, and that's going to be 4 and 16. Does 4 go into 81 evenly? No. Does 16 go into 81 evenly? No. 5 does not. 6 does not. 7, 8. 8 and 8, and 8 does not either. And you don't have the same variable. I have V's over here and W here, so I can't factor out a V or a W because it's not in both terms. So there is no greatest common factor. When you have two terms and there is a minus sign in between, it might be a difference of two perfect squares. So I'm going to take the square root of this. I know I'm going to set it up like this. Now, the square root of 81, what number times what number gives you 81? What number times itself gives you 81? 9. Okay, so that means 9 goes here. Then I have the v squared. What times what gives you v squared? That would be a v. So you've taken the square root, you've got 9v as your first term for each of those factors. Then you take the square root of the second term. What number times itself gives you 64? 8. So that means there's an 8 here and an 8 here. And the square root of w squared is w. W times w gives you w squared. I'm going to put a plus sign here and a minus sign here. And this is your factorization. What questions do you have for that? All right, let's take a look at B. 1 minus 144 q squared. First of all, check for a greatest common factor. Your smallest coefficient is 1. Does 1 go into 144? Yeah, but that's not going to be helpful. If I factor out a 1, I still get the same thing. There is no variable, so that means I don't have a greatest common factor. I do see that this is a difference, subtraction of two perfect squares. So I know I'm going to set this up as two sets of parentheses. What is the square root of 1? Meaning what times what gives us that 1? 1. So that goes as your first term in each factor. Then you go to the second. 144 q squared. So what number times itself gives you 144? 12. But don't forget, we have a q squared also. So that means this is 12q and 12q. You put a plus sign here and a minus sign in the second set of factors, and that is your answer. The difference of two perfect squares, this is my favorite kind of factoring. Because it's like, oh, yeah, it's quick. It's easy. All right, so take a look at letter C. See if you can do letter C on your own. Okay. Viviana? Mm-hmm. So x squared minus 36. You should check for a greatest common factor first. You have an x here, but no x over here. And you have a 1. So 1 can go into anything, so that's not helpful. No greatest common factor. You see a difference of what looks like two perfect squares. So if you were to write this out, x squared minus 6, take the square root. What is the square root of x squared? X. So put that as your first part. And the second one, take the square root of 36. What number times itself gives you 36? 6. That is your second term for both factors. Put a plus sign in here and a minus sign here, and that's your answer. Anybody have x plus 6, x minus 6? Yeah, that's not too bad, right? It gets a little bit harder because sometimes it won't be an x squared, it might be an x to the 4th. Okay, and I think that's on the next page over. So let's see if we can do D, and then we'll get to the next side. Greatest common factor. You do need to look for that first. I've got 9. Does 9 go into 25 evenly? No. 3 would be the next factor. No. And then 1. So no GCF. Take the square root. So what is the square root of 9x squared? 3x. And 3x over here. What is the square root of 25? 5. And 5 here. Put a plus sign and a minus sign, and that's your answer. And why does this work? Because if you look at it and distribute, okay, first times first, first times first is going to give you 9x squared. Outside times outside is negative 15x. And then I do the inside times inside, that gives you the positive 15x. And then 5 times negative 5 is negative 25. So when you have the difference of two perfect squares, if you multiply it out, these middle two will always cancel out. That's why if you redistribute and multiply it out, you get what you originally had, because the two middle terms cancel out. Okay? But this is the factorization. All right, let's turn the page. And let's see if we can do, let me see if I can find. These are all x squareds. Okay. All right, let's do letter E. Let's just go with the flow. Letter E. So look for a greatest common factor. Do I have a greatest common factor? Check again. Start with your smallest coefficient. You have a 4. Does 4 go into 36 evenly? Yes. So we need to divide by 4. Can I divide by an x from both of those terms? No. So just the 4. So that 4 comes out in front. That is your greatest common factor. 4 divided by 4 is 1. You're left with x squared minus, what is 36 divided by 4? 9. And you're like, oh, I'm done. But take a look. This is a difference of two perfect squares. So you need to look and make sure you can't factor anymore, but here we can. So if I take the square root here, what is the square root of x squared? No, that's not right. It's an x, right? And then take the square root of 9. What's the square root of 9? What times what gives you 9? 3. Put a plus sign and a minus sign. Okay, these aren't squared, so that should be good. And then don't forget, you need to bring this 4 down because you factored that out initially. So the factorization is 4 times x plus 3 times x minus 3. Excuse me. Questions there? All right, how much time do we have? 12:48. Let's see. G looks pretty easy. Could try F. Let's do. Let's try F. Let's do F. So 100x squared minus 49. Not right now. You've missed most of it. Just hang right here. Can you wait like 3 minutes? 3 minutes. I guess you can't wait. I love it when you guys like smirk and smile. I feel it. I totally feel it. All right, so I look for a greatest common factor. 49. Does 49 go into 100? No. 49. 7 times 7. Okay, 7 doesn't go into 100, so I think that's it. So no GCF. I see a difference of what I hope is 2 perfect squares. What is the square root of 100? 10. I have an x, and so that means 10x goes over here. Take the square root of 49, which is 7 times 7. Put a plus sign in between those two and a minus sign here. And this is your final answer.
Oh, so we just found the square roots?
Yep. Write the first one down as the first part of each factor, and the second one is the second half of each factor. X squared minus 9. What is that going to break down into? Anyone? That's right. X plus 3 times x minus 3. Take the square root, take the square root. Bada boom, bada bing. H. 49 is only going to be 49 and 7. So we're going to break it down. The square root of 64. So you're saying what times what gives you 64? Come on. 8. And you've got an x squared, so that's an x. X times x gives you x squared. What's the square root of 49? 7. Put a plus sign and a minus sign. There you go. Talk to me about I. What do I need to look for first with I? Yes, excellent. Give that man a piece of candy. I will. So divide by 5, and you're left with 5 divided by 5. That simplifies out. I have x squared minus, what's 500 divided by 5? 100. And hopefully you notice, x squared minus 100. That is a difference of 2 perfect squares. So take the square root, write that as 2 sets of factors. The square root of x squared is x. The square root of 100 is 10. We put a plus sign and a minus sign, and don't forget the 5. Okay? All right. So it is study hall time. Before you totally break for study hall, let me remind you, homework number 4, which is the last homework for this semester, is due on Friday. And it is all about this difference of 2 squares. Okay? So homework number 4 due on Friday. You can work on it. If you have not finished homework 1 through 3, please do that as soon as possible. Also, don't forget you have the weekly Canvas activities for 12-1 and for, I think it's 11, maybe 17, those 2 weeks. Those are still open. This one, the 11-17 one, is going to be closed on Friday, after Friday at midnight. Okay? All right, nice job. The time